The water supply for a hydroelectric plant is a reservoir with a large surface area. We're going to use that, right? An outlet pipe takes water to a turbine. All right. State the difference in terms of velocity between laminar and turbulent flow. So laminar is like, it's all the little streamlines are all parallel to each other, right? Laminar, and turbulent is like, whoa, right? Okay, so talk about that, right? What's the difference between that in terms of the velocity? Okay, in turbulent flow, you have high velocity and low velocity, and the flow lines are not parallel to each other, right? They're in all different directions. So yeah, see if you can get that right. And then it says, show using the Bernoulli equation that the speed of the water as it enters the turbine is given by, this is basically Torricelli's theorem, right? So what Bernoulli is P1 plus rho GH1 plus 1/2 rho V1 squared is equal to P2 plus rho GH2 plus 1/2 rho V2 squared, right? Okay, so V, this velocity there is V2, right? That's what we're trying to solve for. That's that V, right? And the H really is this H here, okay? So I think what we can do is we can say that the pressure is the same here and here, that there's atmospheric pressure there and it doesn't really change, okay? I think we can say that H2 is 0, right? I think we can say that because the reservoir is so large, it's a very large surface area, right? This velocity is essentially 0, and then you set this equal to this, and you can solve for the V, okay? Happy hunting on that one. Let's look at the next one here. All right. The following data are available: the density of the water, the viscosity of the water, and the velocity. Don't confuse those, right? And then the diameter of the outlet pipe. So the radius is 0.300, right? So calculate the Reynolds number. Reynolds number is, what is it? It's all the inertial things on the top and the viscous things on the bottom. So VR times the density, right, over the viscosity. So just plug it in. There's your velocity. This is your radius, right? You'll be surprised when you look at the data packet or the mark scheme, right? Here's the viscosity. Plug that in for the viscosity. Yeah, there you go. Okay, and then is it reasonable to assume that it's laminar? Well, if the Reynolds number is less than 1,000, it's laminar. So make that comparison, make that point. If it's less than that, then yeah, it could be laminar. If it's more than that, then it probably is not laminar. Okay, yeah. This one's not ambiguous. So anyway.